cloud services and why they are so important. And it really is timely considering that Amazon Web Services had a really big outage a few weeks ago, and now Microsoft Azure also had a big outage a few weeks ago as well. So we called up our good friends at Aptos, and we've got Pranav Raval, who is the head of infrastructure at Aptos Labs, and he's also the head of Shelby. He's going to be telling us all about that and more, and we're going to be chatting all things Aptos today. So I'm quite excited for the show. Pranav, first things first, how are you today, sir? How are you doing?
I'm doing great. It's bright and early here in Palo Alto, California, and I'm excited to be on your show.
Beautiful. It's great. It's great to have you here. And I think first things first, for anyone out there in the industry that doesn't know you, can you give us a brief rundown of your history in the industry? You've been in Silicon Valley for a very long time, and I think it's worth telling our audience a little bit about your background before we get into the nuts and bolts of today's show.
Yeah, happy to. Chronologically, I've been with Aptos Labs for pretty much since the beginning, since the company was founded. Before that, I was head of batch compute at Meta/Facebook. So we built the core compute engines to process all of Facebook analytics data, Facebook, Instagram, WhatsApp, all of the data. And we built a kind of an exabyte scale data warehouse, pretty large scale processing. And before that, I've done few things with startup, mid-sized companies, mostly into high performance distributed systems.
If I can, how did you first kind of get introduced to the world of crypto? Was it through Bitcoin or anything like that before you got into the whole Meta project and obviously everything that the team tried to do there with Libra before it was unceremoniously shut down?
Yeah, no, great question. I think in around 2017, I was not that early to the whole crypto bandwagon, but around 2017, 18, I remember reading Bitcoin white paper, and it kind of blew my mind away. I'm like, oh, wow, this is incredible. I've been keeping an eye on things. In 21, though between 17 and 21, I was still pretty busy with Meta. In 21, I had a forced kind of health break for a couple of months, and then it just makes you super kind of retrospective, prospective, what you want to do going forward. And the one thing that bothered me, I felt like there has to be a better payment mechanism outside ads and subscriptions on internet. And that led me down to the crypto rabbit hole. And then I contacted the DM team. I'd worked very closely with Avery back then at the core infrastructure build out. I knew it's an amazing team that's building blockchain for Meta. I talked to them. They said, "Well, let's just wait a few more months. We are we are taking the whole project out on our own." And so that's when I decided to join them.
Beautiful. Look, I've had some interesting conversations with a few different people in the industry, and it's very interesting how everyone that was involved in Libra went off in different directions. David Marcus went off and did Lightspark. Lightning payments on Bitcoin. Avery went the route of Aptos. I know quite a few guys from the Sui team also came out of this sort of Libra project. It's quite amazing that so many people with this shared background have gone on to have different flavors of, crypto-based payments or protocols, whether it's Bitcoin-based or smart contract-based. Why didn't everyone do the same thing?
Yeah, that's again like this. It kind of, in some sense, shows the potential that we have, right? There are so many different routes you can take. For me, the thesis was that if the decentralized systems have a future, it's going to require incredible amount of engineering and scale. And I've seen this. I know that the Aptos team was pretty much handpicked to build the core infrastructure at Meta. Like everybody was handpicked as a lead bunch of engineers like who have done amazing job at infrastructure build out for Instagram and core Meta Infra. They were handpicked to build the blockchain. I'm like, okay, if somebody who can build a scalable blockchain, it's this team. And so I joined them. So I think it just shows the potential that we have. There are a lot of problems to solve, right, in decentralized infrastructure, and different people are following different theses.
Pranav, I find it very interesting that we keep seeing these centralized cloud services go down. I mean, it doesn't happen that often, but when it does, it's pretty much AWS, and then half of the internet doesn't work. How is it in 2025 that is still a thing?
That's that's a very good question. We have first-hand experience some of the big outages, even in the Meta infrastructure. I think this kind of a function of a system that continues to grow over time. Um, and what happens is, and primarily, if you look at the cloud services at a high level, you can draw there is a foundational layer that is generally known as control plane. And the control plane over time becomes this somewhat gnarly set of dependent services. There is configuration, there is your storage, there is your DNS lookup, there is your container deployment, there is all sorts of services. And there is this interdependency between services, and each service is supposed to be highly resilient. Um, but what happens, there are a couple of known failure patterns that I've experienced. Failure pattern one is that because the entire industry wants to bring so much efficiency, it is very easy to push changes through many clusters all at once, right? And then sometimes what you see is like there is a false or there is a slightly wrong configuration change that gets pushed. And configuration changes are notorious because they do not compile. You sometimes, right before you push, you test everything, right before you push, there is an extra character that gets added because of a misclick, and then the whole configuration gets pushed on the cluster. The service cannot run. All the dependent services go down. Now you do not know what was your last known state. You do not even kind of fully understand the dependency tree. And slowly the whole cluster just starts coming down. And then you have to slowly start unpacking. And that takes hours and hours and hours to restore to a healthy state. It's a fully globally distributed system with all of these dependencies. You have to start with, starting the base service, bringing that to the right binary level, right known state, then the next service, the next year, and slowly see, watch, observe, everything is looking good. The other thing is then all the services are also constantly retrying, that is not shut down. As soon as the service come down, it gets slammed with what we call thundering herd of requests. And so, there are protections that you tend to put in place. But yeah, so in 2025, it's the sophistication of infrastructure automation combined with your ability to push a lot of like large impacting changes very quickly, that causes a lot of this failure and outages.
I find it, pretty surprising that it does take this long because, when we talk about centralized services, we think it would be easy. But I can imagine like the most recent AWS outage. I mean, there was a lot of different websites and services impacted by this. And it must be like the panic stations, all hands on deck for the entire AWS team. And I'm sure that's like more than 10,000 people, trying to figure out what's going on. Like, is that the hardest part when this happens? Like, okay, what broke and how do we fix that?
Yeah, I think again, the services are individually designed very well, very resilient. It is understanding your services position with regard to the broader kind of deployment model, and beyond a certain scale, like not as like, you as an engineer do not have the entire picture. Also, like for example, the DNS lookup service that failed, that's a classic one. It just tends to take down so many services because you cannot connect and you're just shutting down. In fact, that in one outage at Meta, like our login with the Meta systems just stopped working. And so for you to debug, yeah, you cannot even log into the system anymore. So somebody had to go and manually kind of, restart some machines in a data center, and then your entry, even your badge wouldn't work. Like, so it's this cascading failure, right? That's the hardest part. If you like, engineers know their services inside out, they know it really, really well. Small failures happen all the time. They quickly recover. Nobody even knows about it, right? And so this is the large scale failures is generally this cascading failures of services that just become very hard to recover from. Um, yeah, I think that's pretty much the hardest part in recovery.
Let's talk about the future, which we all like to believe is decentralized systems, and we know they work from a blockchain sense for payment systems, for smart contract functionality. But when it comes to decentralized cloud infrastructure, why is this a better alternative to centralized services that have a huge amount of capital, a huge amount of infrastructure and resource to run these things well? all that being said, they still fail. Why is decentralized infrastructure better?
Yeah, no, it's a very intriguing question because on the surface you would think otherwise, right? And there are two reasons. One is the decentralized systems, by definition, are extremely resilient to failures. Like, we build system not for resilient, even for malicious behavior, right? Somebody is actually always trying to take down your service, not just by infra, but even by injecting bad code in your system. So and then operationally also, we do not depend on a single network. For example, if you think about, let's take Aptos as an example, we have 150 plus nodes they run across the entire world on many, many different infrastructures, right? So one single outage in one network or one DNS failure, lookup failure in one area does not take down the blockchain. So that's a very simple, like, by nature, the systems are resilient. And then once we talk about Shelby as like the first installment and the big step in building decentralized cloud, we'll see that how Shelby kind of then depends, the whole control plane of Shelby is this highly scalable and performant blockchain, which runs in a decentralized way. So there are two reasons why this is Shelby would be more resilient than any other cloud systems. One is that the control plane is the blockchain where operationally all the operators operate the chain individually, right? There are all the operators, there is no one push, right? So it just takes away that one push deployment error that we talked about. Like, hey, I had this one bad push, it went everywhere. Also, because it's a ledger, it's immutable. Even if there is a configuration that's a bad transaction gets pushed, you just have to revert that transaction and the last known state. It's very easy for you to recover from a bad so all the configuration, all the coordination, where all the rest of the nodes are, their URLs, their lookup, all of that happen on the blockchain itself. So the control plane is extremely resilient, by definition, does not have this single push failures, and is kind of immune to, like, one other failure mode I've seen is like somebody by mistake deletes a lot of data in production. They are thinking they're operating with their local environment, they delete and drop their database, and before you know, they realize that, oh, oops, I deleted it in production. And that's, like, again, a common human error. And again, blockchains are very, very resilient to those kind of human errors as well. You can't just go and delete blockchain. So because, like, how the system is built, it's fundamentally more resilient than how centralized systems are built right now.
I found your tweet that you recently put out. I think it was towards the end of October, citing Jump Crypto and them talking about building out Shelby with Aptos. Can you just give us a TLDR on what Shelby actually is and what people can do with it?
Yeah. And even before we go into Shelby, let me give you a background of, like, why even we are building this. So, and let's talk about the state of blockchains right now. It's an amazing technology, globally decentralized ledger. But if you think about how they work, you have all of this hundreds of nodes. They have to agree on the state of the blockchain through this consensus mechanism, right? And then because every node has to have the state, you replicate the data hundreds of times across all the nodes, right? So when you have this much of data replication, and when you have a very small block time within which you have to execute your transactions, update the state, what you are limited by, what you start thinking is, you kind of start thinking yourself within those parameters, within that bounding box. And so because of that, we believe that fundamentally the ambition of Web3 is limiting right now, because you are building for just that technology, and you can say, okay, I can trade, I can swap, I can, it's a small data, small compute, right? So your kind of mindset is about small data, small compute. When we look at big tech, it's all about not big, massive data, massive compute. And that is where the value unlock happens, right? But in decentralized systems, we just don't think that way. We just think that we are very limited by whatever the blockchains provide us. And so when Jump Crypto and Aptos Labs, we both are very, very infra native teams. I mentioned about the background of Aptos. We just built Facebook's core infrastructure. And Jump Crypto, the team comes from building high-frequency trading systems. So those are couple like big tech and HFT systems are where you are constantly pushing the boundaries of technically what is possible from performance and scale point of view. And then we started kind of brainstorming the state of infrastructure. And what we realize is that right now, A, the limitations, and B, the first thing that we need to do is allow people to put a lot of data, store, serve, and process a lot of data at scale. And that is where Shelby was born. So Shelby is the first decentralized hot storage tier. Think about Amazon S3 equivalent, which is globally uh, distributed. It is as resilient, as available, if not more. We talked about that as clouds. It is going to be as performant, maybe even more performant. We are going to publish some benchmarks as we hit testnet. And the most interesting thing that we saw is like Shelby is actually going to be cheaper than the centralized clouds as well. So I think we had two theses. A, allow the developers to start thinking big by having very scalable infrastructure. And B, decentralized systems cannot take a step back. It cannot mean it is slow. It cannot mean it is cumbersome to use. And it cannot mean it is expensive. So with Shelby, we are proving both of the theses. And we are very excited about that.
When it comes to what you're doing, would I be right in assuming things like EigenCloud and Filecoin are serving similar use cases, albeit on different blockchains?
Without comparing to anybody specific, in current state of decentralized systems, that is not a single storage system that is built for read optimization. They are built for primarily storing data, and that serves a purpose. You have data that is censorship resistant. It's there. It stores data for that is permanence. That is long-term guarantees. It's a great backup and archiving systems. When you talk about the read optimized system, we want to have data that you can start accessing. Your time to first byte should be a few hundred milliseconds. And then you should be able to serve out tens to hundreds of gigabytes per second, right? So no system exists. So this is Shelby is in a category of its own, even though, yes, bunch of decentralized storage systems exist. The hot storage tier that is optimized for highly scalable reads is completely missing. Shelby is the first of its kind.
Okay, so let's talk about Shelby more specifically, and I've got this Jump Crypto thread open, which is really great, and in like 7 succinct points, it kind of breaks down what Shelby is and who it serves. But you can probably explain it better than me. So, what is the TLDR, and who will be using Shelby once it's completely live and open to the public?
Yes, yes. I think there are many interesting use cases which are emerging. One key thesis was that in the world of AI, like we have seen with big tech, there is a lot of data get consolidated in 3, 4 big silos. All of the value that is earned from your data gets accrued to some very handful of big companies. With AI, it's kind of poised to get even worse. Right, be like even before we released Shelby, my kind of Chat GPT instance knew Shelby inside out completely. So now, and people routinely ask now about health, their personal health, and so like AI is in some sense your data lock-in is even more scarier, and so there is giving ownership back to users such that your context can be easily portable, can be moved around, while you can feed this tens of gigabytes per second throughput to AI engines and train your models differently. You selectively participate where you want to participate. So that was one bucket that we are excited about. The second bucket we are excited about is the creator economy, right? There is the attention economy and creator, like any creator that becomes sufficiently big, they just start demanding more and more autonomy from the platforms. The same platforms, they're kind of they push them up. Now they kind of start running against algorithmic biases. They start they might want to have they cannot speak their mind freely. There's a bunch of different issues, and also different monetization models. Like we are very excited about how creator economy and prediction. So creators can start having prediction markets right next to their content, right? And have a new revenue stream come. And that is where they want verifiable content, because you have now settled a prediction, and here is the content sitting on Shelby, verifiable. Nobody has touched it since then. You can go and verify and make sure that that it's settled correctly. That's another use case. And as I mentioned, if you are equally performant and even cheaper than current clouds, that opens many other use cases that we had not even thought of before. And now people are even reaching out to us from different walks of life, and even people who are not decentralization or Web3 native. They're like, oh wow, yeah, this works. This is cheaper. When can I use it? And so of course, there is the deep in, and some of those use cases are also very clear clear match for Shelby. They are generating, all the sensors are generating ton of data. You want to put it in one place. You want to have a data marketplace. You want to sell your data. So Shelby puts control back in the hands of the owner of the data. So you can figure out how you want to monetize. You can have token gated content. You can have payment gated content. You can have time bound content. Like there is a bunch of ways you can monetize the data. So a lot of developers are playing around with interesting models right now.
Beautiful. When I think about this as an alternative to AWS, my mind jumps to two conclusions. At what point do people start saying, "Okay, I'm done with the centralized, big tech provider, and I want to go and use something like Shelby"? And then, secondly, what guarantees can we as an industry give people that they're not going to suffer the same issues that they had with AWS and everyone else with outages?
Yeah, so I think let me answer the second point first, right? Again, as we set out to build Shelby, we wanted to make sure that there is not a single parameter where Shelby has any gaps. So if you look at the Shelby white paper, we by design, we guarantee 11 nines of durability, which is same as AWS. We guarantee 4 9 of availability, but it should be even more because of the inherent resilience that we have talked about. And so, like, the proof will be in the pudding. One thing what we have started seeing is the performance proof. So Shelby DevNet is live, and people are building against Shelby. They upload large video data, and then in the Shelby Explorer, there is a preview button. If it's a video, it shows you preview, and they click on the preview, and this video just starts streaming in 4K, and they're like, wait, is this coming from decentralized system? Are you sure it's not coming from some cache? Like that's too fast. Like, no, it is, the system is stitching together all of your data blobs, I mean, the chunks together, streaming it out, and here is your proof on performance. So we have to provide proof point on performance, proof point on scale, proof point on resiliency. We believe, like, we have come from the background of building highly scalable systems, so we believe in benchmarks. We believe in benchmarks which are neutral, which are open source, that people can verify, right? So we, in the process, will be putting out a lot of these benchmarks. We are not going to say, oh, trust us, it's going to be great. It's like, hey, here are the benchmarks. Here's how it compares. You see it for yourself. So yeah, that's the second question first. And the first question, I think, look, again, the clouds have had probably now 15 plus years of runway. They have built some amazing systems. They've enabled incredible innovation, and there are a ton of different services, but foundational layer still remains data, right? So what generally you put in your relational databases, you can put on very scalable blockchains, not fully, but almost there. What you put on your data, kind of on your blob storage, or even on your data lakes for your analytics processing, you can start putting on Shelby. Very soon, we are going to put compute next to Shelby. There's going to be CPU and GPU, and you can start having serverless computes, and even analytics processing. All of that would be available. But again, clouds provide you a ton of different services. So, one service at a time, based on the feedback we get from our users, we are going to start chipping away. But the foundational layer still remains the data. And if you solve the data problem at scale, the other services, and then compute, then everything else starts falling in place relatively kind of smoothly.
One of the interesting pieces of the puzzle that I think we need to jump into a little bit, and we've had conversations with Austin Federa at 00. Well, I have a number of times, and he's been on the show before. The Jump Crypto thread talks about 00 actual physical infrastructure. The fiber network is a great part of this puzzle, right? Because if we're all running on the same underground cables and one of them breaks, and we were all relying on centralized service providers to do that, that's a problem. That's a physical infrastructure problem that needs to get fixed. And if we have decentralized alternatives that are running on infrastructure that's being rolled out by a decentralized network service provider, that's fantastic. Does 00 directly fit into this equation, or is it just an example of a decentralized service provider with physical infrastructure that could be a very important part of this puzzle as we move to more decentralized systems versus centralized cloud services?
Yeah, so look, network backbone is absolutely critical. You want to move a lot of data very fast without competing with all the open traffic, right? So just building that fast lane movement is absolutely critical for Shelby, and we are going to partner with 00, rely on the bandwidth that they bring, that they provide. But having said that, that's just one part of the puzzle. Like, I jokingly say that you can't take an old family car, put it on a racetrack, and then expect it to go 200 miles an hour, right? So even though there is a high performance network, there are many pieces that need to come together when you operate a decentralized system. So the number one over there is incentives. Incentives really need to align. And so Shelby is the first protocol that has read, it's the storage in the first storage protocol with read incentives. And so all the participants are highly incentivized to serve out data as fast as possible, because if you don't, somebody else will, and you'll miss out on kind of your revenue opportunity. The second is the dedicated fiber, is another pillar that we talked about with 00. The third is auditing protocol. So you have all of these node operators. They are saying, oh, we are storing half petabyte of data each. How do you prove that they are actually storing the data? And when it comes to serving, they're going to serve it out. Again, it's not centrally owned. So you have to audit the data, and done naively, your audit itself will take up all available bandwidth. So it's a very interesting challenge to have very high auditing guarantees while making the bandwidth utilization as low as possible. So there is an auditing protocol. The fourth is how do you lay out the data on the network? So again, done naively, a lot of the systems just replicate it 5 times. Like, hey, let's replicate the data 5 times. Even if 2 nodes go down, 3 nodes go down, 4 nodes go down, your data is still available. What ends up happening is that now your system is much more expensive to use. Again, we want to build a cheaper system. So we are using the scheme. This is the thing called, there's a scheme called erasure coding scheme that takes your data, chunks it into different chunks. And even if you lose some chunks, you can mathematically recompute the lost data, the way the data is laid out and your bytes are laid out. And this is a known technique that's been used in centralized cloud. We have just found a very novel an interesting erasure coding scheme that allows us to find this perfect balance between storage overhead and bandwidth overhead. So that, again, this is where our and Jump Crypto's background comes in handy. The fifth pillar is battled hardened software. So we are going to heavily leverage Jump's in-house storage infra, the software, so some components of their in-house storage infrastructure. I reminded everybody at the beginning of our project that the last time Facebook rolled out a highly scalable hot storage protocol, it took them few years to build and few years to stabilize. And Jump team said it was the same here. But now that we have better hardened software, we are going to leverage that. And they have put a ton of optimizations. If you think about, there are a bunch of libraries we are going to also use from FireDancer. And if you think about just reading and writing files, it goes through many layers in your operating system to your so between your disk and your network buffers, there are still many layers. Many time data gets copied over. The jump team has the stack which kind of bypasses everything from disk to network. There is minimal overhead. Our focus is to make sure that Shelby can consume all available network bandwidth. So this battle hardened software allows us to go to market much faster and bring the equivalent performance and resiliency that I've been talking about. And the last one, because it's a decentralized system, you cannot put it behind a centralized control plane and coordination layer. And that is where Aptos comes into play. That it's a highly scalable, high performance, low latency, low gas fee coordination layer, and then fits right into the puzzle. So all of these six pillars have come together that allows us to build. So yes, while 00 is a very critical pillar, we have like 6 total pillars that makes Shelby what it is.
It sounds very complicated, if I'm very honest. But I mean, like that's why you guys are
and that's why nobody has built it so far. To be honest,
Yeah.
it's a very non-trivial pursuit to build a decentralized storage, and there are like many interesting problems that arise with hotspots and many different things that we can talk about some other time.
Yeah. Look, we could probably speak for ages. We aim for 45 minutes, so I've probably got another 15 minutes, and I know that you probably have a very busy day ahead of you. So I'll try and keep it shorter than that. My next question is there actually enough infrastructure out there to serve these needs, right? I mean, are there enough data centers and stuff that would want to run, I guess it would be a node, for Shelby? Or maybe you can talk a little bit more about, hey, I have some infrastructure, or I have some data centers, XYZ. I want to, contribute to the network and earn some money for doing that. How do I do that? What does that look like?
Yeah, that's an excellent question, and it's actually a very, very valid question, and nobody has asked me it so far. So thank you for asking the question. So we are partnering with a bunch of data centers and bunch of node infra providers. And slowly our network coverage is going to grow. So we are going to provide a list of data centers where we have connectivity and where we have the supply, because the nodes are not going to be just a simple like, hey, here is some compute, here is some storage. It's a highly kind of storage heavy nodes. You are going to have lots of disks on a single machine, and we need to make sure with the kind of infra providers that the supply is there. At Shelby scales, and then now we onboard a pretty large customer, and then they're like, oh yeah, I want petabytes of more data. We cannot say, oh yeah, we're gonna put some orders, see you in 6 months. Like that's not gonna happen, right? That's not gonna work. And so it is a very interesting supply chain problem as well. And that is why I appreciate you asking and kind of grokking that problem. We absolutely see that we will continue going further upstream as Shelby scales. Right, at some point we'll be. So right now we are partnering with infra providers, and then we'll be working very closely with them to make sure that their upstream supply chain is ready to serve Shelby scale and demand as we grow, while having global coverage. A lot of our users are in different parts of the world. There is concentration per use case. We want to serve them out as well. So that is like the network coverage and scaling the network with the users is going to be a very, very interesting operational challenge for us. But yeah, all the early stages are laid out pretty well, and we are looking forward to kind of growing with Shelby.
The next thing that makes me think of is something that Vitalik Buterin talks about often, and how decentralized the network is. Directly relates to how secure it is, but also, I guess in this instance, how quickly it would be able to serve data and the needs of your users. Does that mean you have to be geographically dispersed where these data centers are? I mean, across different continents and those kind of things. And is there sort of a rule of thumb that you will kind of look to say, like, we are sufficiently decentralized to claim that we are a decentralized cloud service?
That's a great point. Shelby, in a way, so first of all, is going to be operated by different node operators across the globe. We are going to have presence in North America, Europe, Central Europe, Western Europe, APAC regions. We are seeing now a lot of demand from India, Vietnam, also the MENA regions. And so we are going to have our coverage in all of those regions. In terms of like what is the Nakamoto coefficient equivalent for Shelby, that's a good question. I have not yeah, let's talk about that in our next in our next conversation. It is, but look, the from the stake distribution that remains the same. So I think it's going to be highly decentralized. Aptos has a pretty good Nakamoto coefficient, and Shelby should have. There is all the reasons that Shelby's stake distribution would be as good as any first-class blockchain that is operating right now.
Yeah, look, I think when it comes to that, it's a lot more relevant to a an out and out blockchain like or a cryptocurrency or a payments network like Bitcoin than it is to sort of a data infrastructure. And to be honest, like if all I'm wanting is really good data availability, as long as the server's close by and I have a cabled connection, I'm going to be happy. I don't care too much if it's decentralized. But there'll be some purists out there that would want to know. So you can take that one back to the team, and I'll let you guys have a bit of a caucus, and I'll pick your brain again the next time.
Nice.
Yeah, I guess Pranav, just to wrap up, what is the next 6 month to 1 year roadmap for Shelby, and how do you foresee the growth of this industry? Do you expect a lot more competitors in this space that are sort of cross-chain native and are serving this use case that you guys are looking to I guess carve out a big share of the market?
Yeah, let's talk about the competitor first, and then I'll talk about the roadmap. Look, any sufficiently successful use case should have competitors. They also make you, they keep you on your toes. You're not complacent. You are always looking to do better. So we look forward to having some good, strong competitors. There are some really good engineers, and they should look at Shelby. There are all the signs. The use cases that we are talking about are incredible. And once Shelby goes live and people see the use case, I'm sure there'll be competition. And we'd love to have competition. That just shows that we're in the right direction when more people want to solve the same problem. The second thing is the Shelby roadmap. So we already have DevNet that's already running. And there is a Discord server that anybody can join. There are a bunch of developers already building on Shelby. The first thing people started playing around with was actually some use cases that we are not even sure Shelby is not even optimized for. They're kind of collaborative editing. I'm like, that may not work. I'm like, oh, it works great. I'm like, oh, wow. I'm very surprised. We didn't test for that. There is a bunch of streaming, there is kind of data marketplaces. And so I invite anybody who's curious, say, just head out there. Our goal is to get a developer who does not know anything about Shelby, going from there to building on Shelby in 30 minutes or less, right? It should be very simple, very straightforward. And we'd love to get feedback from developers, like, was it that, or you're kind of getting stuck in something? We have had some developers their onboarding was pretty easy and straightforward. By year end, bunch of other features are coming, and January we are going to have a testnet, and that is where things get very interesting because, as I mentioned, decentralized storage network can have a lot of interesting problems at scale. At low scale, everything looks great. At high throughput, things get very interesting. And so we are going to start stress testing the system, having global coverage, running all sorts of interesting tests on it. And then as and when we feel, as and when we feel that the network is sufficiently resilient, performant to our satisfaction, and B, our core kind of launch partners who are building with us, they're ready. We are able to serve their users in their geography with the performance that they are happy with. At that point, we are going to go live. The date is TBD for going live, but yeah, we don't anticipate sitting on between testnet to mainnet for a very, very, very long time.
So hopefully sometime in 2026. I'll say it. You don't have to say
Definitely.
it.
Yes, that is for sure. I just don't want to commit to a quarter right now.
Yeah.
But the other thing is like in terms of like the overall roadmap. So that's our right in front of us. There is a bigger roadmap that in fact we have already started working on. One is that Shelby is the hot data storage, but once data is kind of um, data is temporal and data is thermal in nature. So it can get super hot, and then you have to start caching it at all the edges and all the kind of pops. Our data can over time just slowly become cold. Like this. Let's talk about this. Podcast live. People are watching it. Then a lot of people will watch it next week. Few less week after, few less week after. That becomes cold, and so we want to serve the full life cycle, right? So that the burden is not on user that, oh, now the data is cold, let me move it somewhere else, right? So we are going to have the full data life cycle. And the second thing is we are going to start putting compute next to Shelby and start having many, many interesting use cases over there that when you put data and compute together, it becomes an extremely powerful combination.
Yeah, definitely. And then you have the added benefit of having it decentralized. Because I think, talking about AI, and we will definitely have to have you on the show again to talk a little bit about that. But I'd spent some time talking to, Paolo Arduino from Tether about their efforts to build, decentralized AI. And once you realize how centralized these, like ChatGPT is or whatever, like you were saying, you've been talking to your agent for a very long time, probably, directly about Shelby, and it knows everything.
Yeah.
That's in a server somewhere, right? Like that information is being stored somewhere. And
Yeah.
if and when we build the tools that are decentralized, and it means that it's client side or, like locked to a person's device, that becomes incredibly powerful. And I think that's why a lot of us are in this industry, is because we want people to take control of their data and at least have that at their fingertips to be able to know that they're not just passing on all this sensitive data to a centralized service that they don't really know how or where that data is kept. So it's definitely it's a conversation for another day. Pranav, I've
There
stolen a lot
is.
of your time.
Yeah, no, there is a lot to talk about AI. There is a whole other kind of, uh, topic that I haven't talked about today, which is integration with neo clouds and what value Shelby can bring there to the GPU first clouds. So yeah, I'm also looking forward to continuing our conversation some other time soon.
We'll definitely do a round two. I'll make sure that the team makes it happen. But Pranav, thank you so much for your time. We look forward to seeing what happens with Shelby. And you didn't put a quarter on it, but sometime in 2026, we're hoping for mainnet. And I will be among others watching very keenly to see the updates. But thank you so much for joining us. If you're interested in following Pranav on X, his handle is @rpranav. You can find him there. Of course, go ahead and follow Shelby on on X. You can follow Aptos on X for any updates there. Once again, thank you so much for joining Chain Reaction. If this is the first time watching the show, we're here 4 days a week. It's usually Monday, Tuesday, Wednesday, and Friday at 4 p.m. Central European Time or 10 a.m. Eastern Time if you're in the US. Please do set a calendar reminder every day. We have the biggest names in the industry. We unpack the biggest news. And we bring you the best insights in the industry. So thank you so much for watching. If you are interested, I will be at Bitcoin Amsterdam tomorrow. If you're in Amsterdam or the Netherlands for the conference, please come and say hello. I'll be on the main stage at 9:30 talking about Bitcoin treasury companies. It's going to be a really fascinating conversation. I'm also interviewing Safety Namus tomorrow afternoon. But you can keep an eye out on my socials at Gaza_Jenks on X, or the CoinTelegraph account. We'll be posting some updates from Bitcoin Amsterdam as it happens. But until tomorrow or the next day, thank you so much for joining us. Have a fantastic evening, and we'll catch you again next time.